Okay, this is second semester, 7th grade math, Unit 1, Lesson 2. Okay, vocabulary review. All right, what do you call a mathematical sentence with an equal sign? That's a pretty easy one. Can I get somebody to volunteer the answer for that? A mathematical sentence with an equal sign. Nope. An equation, an equal sign, an equation. Oops. Okay, now solve each equation. Now, many of you have gotten pretty good at solving equations. For the most part, the equations we're going to be solving in this unit are pretty easy. Today, the equations we're going to be solving are just one-step equations. So, number 2, who can walk me through this? Solve for L. Alexis. 70. Well, how did you go about doing that? I know you can mentally solve it, but I want you to use inverse operations to solve it. What do I have to do?
You can subtract those two, 20 and 90.
Right, we're going to subtract 20 from both sides of the equation because we got to make sure it stays balanced. Okay? And then we see that this cancels. We know it becomes what? 0. Now, at this point, I don't need you guys to put 0 anymore. I think you guys understand what's happening to it, right? So, L, and what's 90 minus 20? 70. So L equals 70. Okay? Any questions? Okay. Next problem.
The answer is 140.
Okay, well, how'd you get to the answer?
I subtracted minus 40 from both sides.
Okay, so we have n with plus 40, and to get n by itself, we're going to subtract 40 from both sides. Okay. My plus 40 minus 40, they become 0, and n plus 0 is just going to be n. And n is going to equal, what's 180 minus 40? It's going to be 140. So my answer is n equals 140. Chin, can you do number 4 for me? Okay, how did you do that? Walk me through it. Okay, yep. To isolate my variable p, I got to subtract 16 from both sides. Very good. And then my plus 16 minus 16 become what? Well, what happens to this part right here? What happens to positive 16 minus 16? Becomes 0. So then I'm left with what you just said, which is just p equals 90 minus 16, 74. Very good. Okay. So last one, number 5. Who's got number 5 for me? Michaela, go ahead. Right, so we have n plus 22. To isolate n, I got to subtract 22 from both sides of my equation. Okay, and then my positive 22 and my minus 22 become what? Becomes a 0. So I'm left with, on the left-hand side of my equation, s, and s equals what? 158, because 180 minus 52 is 158. So s equals 158. Okay, any questions? Easy stuff. All right. Since I'm using this for the class YouTube channel, I'm going to go ahead and read this section to you. What you'll learn: to classify angles and to work with pairs of angles. How many angles are in a pair? 2. So think about that, because I had a question for the last class, and I just want you to think about a pair is a set of 2, right? Okay. We're going to come back to it in a little bit. New vocabulary. And we have a lot of new vocabulary. I'm sure you've heard this before, though, but so this should be mostly a review for you. But angle, a vertex, an acute angle, a right angle, an obtuse angle, a straight angle, complementary, supplementary, adjacent angles, vertical angles, and congruent angles. So that's a lot of new vocabulary for this unit. Why learn this? Architects think about angles in structures they design. If you can measure angles, you can predict how different geometric figures can fit together. The design of a geodesic dome requires triangles because triangles have exactly 3 angles. They make the dome stable. So if you look at this from where you're at, it's hard to see, but I'll go ahead and enlarge it. So do you see in the photo that it's not really a sphere or part of the sphere? It's actually made up of a bunch of triangles. Okay? And this, I believe, is in, I think it's in Montreal. I'm not sure, but it's in Canada somewhere. And the book does talk about it a little bit. Okay. Now, in lesson 1, we talked about lines, line segments, array. Now, an angle, and here's the symbol for angle. Do you guys see how that's just a little angle, right? An angle is a figure formed by 2 rays with a common endpoint. Remember, a ray has a starting point and it extends infinitely in one direction, right? So when you have 2 rays that have the same starting point and they extend infinitely and they're not on top of each other, they're extending in different directions, they form an angle. Okay? You can call the angle, let me change this. Well, not to below, but to the right. So we're talking about this angle right here. Angle DCE, angle ECD, angle C, or angle 1. Do you see that there's a 1 here? Okay, and the reason why we have these different ways to name the angle, we have to make sure it's clear which angle we're talking about. And so sometimes, like in this particular situation, it's obvious if I said angle C that I'm talking about this angle right here. Okay? Now notice right here, angle DCE. Do you see the middle letter is C? The middle letter is C. Do you guys see that? And do you see that for if I name it angle DCE, DCE, we're talking about angle C, right? Or that's another way to say the same angle is angle ECD, ECD. But the middle letter stays the same. Do you guys understand? You're going to see an example later why we have to use sometimes 3 letters to say which angle we're talking about. Okay? So also, another way you might name an angle is they might put a number at the angle, angle 1. Or they just might say the letter, because that is, it's obvious which angle they're talking about, angle C. Does that make sense? So 4 different ways they might name the angle. All right. Now, something I want you to notice. A vertex is the point of intersection of 2 sides of an angle or figure. Here's how I remember vertex. Vertex, do you see that? V. Try and remember the word vertex. A vertex is the point of intersection of 2 sides of an angle or figure. The plural, that means more than one vertex, is what? Vertices. Okay? Now this should all be reviewed for you. Acute angle. It's an angle from 0. An angle, is 0 degrees an angle? Would that be acute if it was 0 degrees? No, it says between, right? So that means it's got to be a little bit more than 0. It doesn't have to be a lot more, just a little bit more. So 0.000 degrees is acute. But if you say 0 degrees, it's not an acute angle. Do you guys understand? Now, it says between 0 and 90. If I'm 90 degrees, I'm at an acute angle. No, but it could be a little less. It could be 89.9 degrees, and that's acute. So do you guys understand what they mean by between 0 and 90 degrees? It's not 0. It can't be 90. It's between 0 and 90. You guys understand? Okay, now a right angle. A right angle is exactly 90 degrees. It's not a little more than 90 degrees. It's not a little less. It's exactly 90 degrees. Do you guys understand? Okay. An obtuse angle is more than 90 degrees, but less than 180 degrees. Are we good on that one? Okay. And here's an example one. And then a straight angle. I feel like sometimes students have a hard time with this one, but maybe this will help you out. Here are my two rays. They meet at that point. And then the angle formed is 180 degrees. Okay? That's called a straight angle. Two rays that meet at a point and they extend in opposite directions is a straight angle. Okay, are we good? So any questions about acute angles, right angles, obtuse angles, or straight angles? This should be all review for you. All right, moving along. Architecture. Part of a geodesic dome is shown at the right. Identify all the acute angles. Okay, so I want, for now I just want 3. Could you give me 3 acute angles? Bryce, can you give me one? Use 3 letters to name it, though. E-N-D, very good. So I'm going to use green for Bryce's example. E-N-D, very good. So angle, E-N-D. And notice the middle letter is talking about N. If I said angle N, would you know which angle I'm talking about? So do you guys see why we have to use 3 letters? Does that make sense? So angle END is correct. Bryce, what's another name to name your angle? Right. So this is the same angle as angle DNE. Do you guys see that? That's another way to name the same angle. Do you guys understand? So DNE or END is the same angle. Does that make sense? Okay, we good? Who's got another example for me? Who's got another acute angle for me? Somebody I haven't heard from. Miranda, go ahead. Angle NDC. Nice, that's a good one. Angle NDC. And there's another way to name that angle. What's the other way to name that angle? CDN. Angle CDN. And notice the middle letter didn't change, but the order that we named the angle did change. Okay, we good? Now, if we would have said angle D, would it have been obvious which one we were talking about? No, because we could have been talking about this angle or this angle, right? Okay, so we have to be familiar with the different ways to name the angles. Robert, can you give me an angle? B-A-N. Nice. So we're talking about B-A-N. Good. Angle B-A-N. Is there another way to name that angle? Angle N-A-B. Very good. Okay, so there's more. I'm not going to get into all of them. We're going to move along. The book gives you the rest of them. What I do want you to figure out over here, angle AFE, they want you to classify that as acute, right, or obtuse. Acute, right, obtuse, or straight. So first of all, we need to find out where angle AFE is. So first we'll take a look, and we'll find angle A is, the first letter A is right here, AFE. So A, F, and E. So they're talking about this angle right here. Is that angle acute, right, obtuse, or straight? Nima? Obtuse. And why did you say it was obtuse? It's more than 90 degrees, right? Very good. So Nima's correct. It is obtuse because angle AFE is greater than 90 degrees, but it's also less than 180 degrees. It's not a straight angle, right? And then less than 180 degrees. Okay, very good. All right, so I'm going to give you 2 words to think about to help you out with the next 2 vocabulary words. The 2 words are common and super, right? So if you were to compare those 2 words, how would you compare those 2 words with each other? Common and super. I'm giving you 2 words. I want you to come up with a word that compares them. Common and super. How would you compare those 2 words? Or explain to me how you would compare those 2 words. Common and super. Nima? I'm sorry, Tata?
So I should compare them?
Compare the word common and super, yes.
Well, common is like everyday, but super is like, oh wow, that's new. And
That's more. New, that's more, right? Okay. So now I want you to think about, I like how you explained that. You might have had a different way to explain it, but it should have been kind of similar, maybe along those ways. But let's take a look at the 2 words I want you to think about now. Complementary, think about the word common, and supplementary, super. This is why I'm trying to get you to mentally separate these 2 things. So the sum of the measure of 2 angles, remember we're talking about pairs? Okay, so we're talking about pair of numbers. The sum of the measure of 2 angle pairs is 90 degrees. That means if you have a pair of angles and they add it to be 90, they are complementary. Remember the word I gave you, common? Complementary? Now, if the sum of 2 angle pairs, 2 angles, is 180 degrees, the angles are supplementary. Remember I gave you that word super? Okay, so I'm trying to get you to think about these separate. I'm trying to give you some words that you know to anchor these vocabulary words to. So common, 2 angles that give me 90. Complementary. Super, 180. Isn't 180 more than 90? Right? So you see how I'm trying to get you to think about these words and connect the vocabulary? Supplementary angles are 2 angles that give me 180 when you add them. Got it? Now, we're going to use what we did in the warm-up and what we did a little last semester to answer this question. So, finding complements and supplements. They're talking about 2 angle pairs that are supplement or complement. Now, let me show you how to set this up in the example, because once you see this, I think you're going to understand how I've been trying to get you to explain your thought process and show your work. If angle A and angle B are supplementary, what does that mean? Somebody explain that to me. If angle A and angle B are supplementary, what does that mean? Think about the words I've been giving you. Robert. If you add them together, they give you 180. So watch this. Now, I'm going to color code what's in this sentence. Angle A. I'm going to write it over here. I got angle A. And I'm going to use what Robert just told me. And this little, it looks kind of like a less than symbol. It's for angle. Somebody got tired of writing the word angle, so they just made that little symbol. Angle A. And then you said angle A plus angle B, and I'll put that here in green. Okay, angle B. You said it equals what? 180. And how'd you know that? Okay, but hold on. What word told us that? Supplementary. And I saw some of you kind of pointing to it. Supplementary means they add up to be 180 degrees. Okay, so they want us to figure out angle B. Do we have all the information we need to figure out angle B? Yes, because there's something I could substitute here, right? What can I substitute, Alexia? Right. Angle A is 37 degrees, so I can substitute for angle A 37 degrees, so I'm going to do that. And then everything else, now it should just look very similar to what we did for the warm-up. So do you see, this came from the word problem. Now we're replacing what we know in the word problem, and now it's just like the warm-up. Instead of putting an x or a variable, we have angle B for my variable. Do you guys understand? How do I solve this? How do I isolate my variable? In this case, my variable is angle B. What do I have to do? I see some of you guys are working on this, so it looks to me like you guys made the connection with what we did in the warm-up right away. There's a few of you just kind of sitting there bunching your faces up. Bryce, what am I going to do to figure out angle B? I need to subtract 37 from both sides, right? So I'm going to do that. Minus 37 degrees from both sides. And when I do that, this cancels out, becomes 0. And what does angle B become? Angle B is left with what? How much is it? Please don't write on my desk. Clean that up, please. So what's it going to be?
47.
Nope. 143. I like that you're trying to do mental math, but try to plug it in and make sure it works. So take your number that you came up with, put it back in, did it work? And then if it didn't, go back, double check it. All right, moving along. Now I need you guys to go ahead and solve this. The problem is just a little bit different. On your own, now you should know how to do this. This is easy math. Now you see the setup. A couple things changed, not much though. Yeah, they're wanting to use angle A again, but they're saying, hey, we want you to find the complement now.
Oh.
So if you look here, my keyword changed. Angle A didn't. Okay, when you're done, put your pencils down so we can go over it. So pretty much all of this is going to stay the same, except for what's my equation going to look like? I need to fix something in my equation.
You have to change 8 to 37.
Hold on. What's this right-hand side of my equation going to be? 90 degrees. And why did you say 90 degrees?
90 is complementary.
Right, complementary angles are two angles that give me 90 degrees, right? When you add them together. Okay, so now we can substitute, right? We already know what angle A is. 37 degrees, okay? And then everything else just remain the same, so here we go. So what do I got to do now? Who can walk me through the rest of this? Somebody I haven't heard from would be nice. Gabby, what's the next thing I got to do? Right, I got to subtract 37 from both sides. 37 degrees here minus 37 degrees minus over here. And so what am I left with? This becomes 0, right? And so I just have angle B on this side. And angle B ends up equaling what? 53 degrees. Nice. Pretty easy, right? Okay, let's move to the next thing. Adjacent angles. Angles that are adjacent, they share a side. So if you look, angle 4 and angle 1 are adjacent to each other. You guys see that? Because they share that side. Does that make sense? But is angle 4 adjacent with angle 2? No. They share a vertex, but they don't share a side, so they're not adjacent to each other. Does that make sense? Okay, but there's another angle that's adjacent to angle 4. What's adjacent to angle 4? Angle 3, very good. So we see that angle 4 is also adjacent to angle 3 because they're next to each other. Okay, does that make sense? All right, so when they share a common side and they meet at the same vertex, they are adjacent. Now, if they don't share a common side, but they share, they are opposite each other, and they meet at the vertex. So two lines that intersect form what are called vertical angles. So let's go through this. All right. So angle 1 and 3 above, these are vertical angles. They meet, they're not adjacent. They meet at the same vertex. Okay, and this is true only for two intersecting lines. If you have more than that, this doesn't necessarily work. Okay, so I have these two lines that cross, they form an intersection, and they form four angles. This comes up quite a bit in math, so I'm trying to get you guys, make sure we get this right. So two lines that intersect form four angles. Angle 1 and angle 3 are vertical angles. Okay, they're not adjacent to each other. A vertical angle, if you have one vertical angle, they are equal to each other, equal measure. So angle 1, and in geometry, we don't say equal measure. We say the word congruent. Okay, and the symbol for congruent is this equal sign with the little wavy on the top. Do you see that? That means same measure. Do you guys understand? Okay, they don't, instead of saying the same measure, in geometry you say congruent. You might even want to use the word equals, but in geometry we're going to say congruent. So angle 1 is an obtuse angle that is congruent to angle 3. And then here's how you would write it out. Do you guys see that? Word congruent, vertical angles. Now, what other angles are vertical angles? Those are the first two pairs. Can you tell me another set that are vertical angles that are equal to each other? What is it? I heard it. 4 and 2. So you have 4 and 2 are also congruent to each other because they are vertical angles. Okay? They're also vertical angles, and they're congruent to each other. So that's easy. Now, back to what we're talking about with adjacent angles. Adjacent angles, 4 and 1, because they share that side, guess what? They are supplementary. That means they add up to be what? 180 degrees. So angle 4, because they are adjacent angles, whenever you have two angles that are right next to each other and they share a side like that and there's a straight line across the bottom, okay, they are supplementary. Now there's some ways that they'll try to trick you. So the key is this has to be straight all the way across and that has to be the shared side. Angle 4 plus angle 1 equals 180. They are supplementary. 180 degrees. Supplementary. All right, so we're going to use that picture right here and that information we just discovered to answer this question. Find the measure of angle 1, 2, 3 for measurement angle 4, that M means measurement angle 4, equals 128. Right? So this is pretty, I'm going to walk you through this. So we know angle 4 equals what? 128 degrees. So I'm just going to write on my picture here 128 degrees. What else is 128 degrees? Angle 2, because they are vertical angles, they're opposite each other on these two intersecting lines. Angle 2 is 128 degrees. Okay? Now, how do we figure out angle 1 and angle 3? How do we figure that out? Because you know 4 and 2 are vertical angles, right? Angle 1 and 3, well, angle 1 is adjacent to 4, and angle 3 is adjacent to 4, and angle 1 is adjacent to 2, and angle 3 is adjacent to 2, right? And what do we know about adjacent angles that are formed by two intersecting lines? What do we know about them? Think about what we did up top. What's that? They form what? They are supplementary. That means the sum of them together is 180. So we can set up my equation. So we know that angle 4 plus angle 1 equals 180 because they are adjacent. That means they're supplementary. And then we know how to set this up and solve it, right? We already know that angle 4 is 128 degrees. And now this is just like what we did before. So whoever has the answer, can you tell me what the solution is going to be? How do we get to the solution? Walk me through it. All the way in the back. Noah. Okay, we're going to subtract from both sides 128 degrees. Okay, and then we see that this cancels out. I'm left with angle 1 is going to equal, what's angle 1 going to equal? 52. 52 degrees. Well, now that we know angle 1 is 52 degrees, do we need to do another equation to figure out what angle 3 is? No, because what kind of angles are 1 and 3? Use the word. They're congruent. That's what the measures are. They're the same measure, so they're congruent. But when they're across from each other like this, they have another name. They're vertical angles. So vertical angles are congruent. Okay, so this angle right here and this angle right here, they meet at the same vertex. They are congruent. This angle over here, angle 2, is opposite in vertical angle 4. Those two are congruent. So I tried to color code this to let you guys see what's up. Okay, are we good? Now, geometry is very visual, so I'm gonna try to use the colors when it can help. I can't always do that, but I feel like in this case I can. Now, here we go. We have another picture. They name the angles different numbers, but it doesn't matter. It doesn't matter what they name those numbers, what those angles, right? Because we know in the picture what is equal to what and what is adjacent to what and how to set up and solve this. So can you guys really quickly on your own solve this? Okay, who can walk me through this problem? So there's a few different steps to it. Chin, thank you for volunteering. What's going on? What's the first part of this problem you want to work on?
So first, I just saw that angle 8 equals 72.
Okay, so you saw angle 8. It's 72 degrees, and now what about that? So we're going to put 72 degrees in my picture. Now what?
And then I saw that angle 8 and angle 6 are congruent.
Angle 8 and angle 6 are congruent because they are what types of angles when they're opposite like that?
Acute.
They are acute, but when they're opposite in an X like that,
Vertical.
they're vertical angles. So because angle 8 and angle 6 are vertical angles, they're opposites in this X. They are congruent. That means they have the same measure. Nice. What else?
And then I subtract 180 minus 72.
Now, why did you choose 180? Explain that process. You're telling me the math, but explain to me like why.
Because angle 5 and angle 7 are supplementary.
No, angle 5 and angle 7 are vertical. They're not supplementary. They're opposite each other. They're going to be equal, right? Congruent because they're opposite. Just like you said. Right, but how do we figure out what angle 5 and angle 7 are?
You subtract.
But before we can get to that why, can somebody help him out? Because he's missing out a key concept here from up above. Your calculations are correct, but I need you to understand why, because you need to understand the vocabulary words. That's what I'm trying to get you to understand. We're going to take what we know to find what we don't know, right? How is what we know related to what we don't know?
Because they're, what's that word?
Begins with an A.
Yeah, I forgot what it's called.
Can you help him out, Tata?
Adjacent.
They're
Yeah,
adjacent. Nice. Okay, so angle 8 is adjacent to 5, and angle 8 is adjacent to 7. And because they're adjacent angles, when you have an intersection like this, they are supplementary. Okay, so now we can set up an equation. We'll go ahead and use angle 8. Angle 8, and what else?
Angle 5.
Okay, angle 5. All right, so use angle 5. What about angle 8 and angle 5? What about them? They're adjacent, but what does that mean when they're adjacent?
They're equal. Yeah, they're
They're supplementary, and what about supplementary angle pairs? What can we say about that?
They both equal. They both add up to 1.
Nice. The sum of both of the adjacent angles equals 180 degrees. Okay. Now let's go about and solve this. Well, we already know that angle 8 is 72 degrees. So now, this is what you're explaining. You're explaining the math. Now I want you to explain the math, Chin.
So you have to subtract 72 from both sides.
Right, we're going to subtract 72 degrees. And this is what you were explaining earlier, but I just want you to connect the y. So when I subtract that, that cancels out, and I get angle 5 equals what? 108. 108 degrees. So if angle 5 equals 108 degrees, we still have one more angle to figure out.
Angle 5 and angle 7 are congruent.
And why are angle 5 and angle 7 congruent?
Because they're both vertical.
They're vertical angles, and vertical angles are congruent. Very good. Question? Go ahead. Okay, we are almost done. Vocabulary. How are vertical angles and adjacent angles different? Who can explain to me? How are vertical angles and adjacent angles different? Gabby? Adjacent shares, so adjacent angles share a side. Okay? Right. Vertical angles meet at the same vertex. And they do not share a side. And do not share a side. Okay? Now, reasoning. What is the sum of the measures of four angles formed by intersecting lines? So if I added up all of these angles, what would it give me back? Nice, 360. Very good. So we can go back and test that. And how did you come up with that? Well, remember, adjacent angles form what? Adjacent angles as a pair, angle pair, what is the total measure for adjacent angles? 180. So let's just look at this. Angle 3 and angle 2, aren't those adjacent? So that angle is going to be how much altogether? So altogether, it's going to be 180 degrees, right? But that's half of my angles, right? So the other half would be 180 also, right? Wouldn't this side over here be 180 also? And so what's 180 plus 180? 360 degrees, okay? If you think about this, you often hear 180 and 360 degrees in sports. So it might be skateboarding, might be snowboarding, it might be basketball. So if in midair you're facing forward, and then when you land, you're facing backwards, what was the degree turn? 180, it was a half turn, right? But if you're moving forward and then jump, or maybe you're in midair, you do a full rotation so that you turn around and you're facing the same way you started out. That's a full turn, that's 360. So a half turn's 180, a full turn's 360. So that's what we're talking about here. Okay? Now, here we go. Classify each of these angles. Acute, right, obtuse, or straight. Measurement angle A is 45. Is that acute, obtuse, or straight? That is acute. Measurement angle B is 105. Obtuse. And then measurement angle C is 75. It's acute. It's between 0 and 90.